Welcome to The Explainer. Today we're unpacking something that is literally reshaping our world. We're doing a deep dive into lithium, and more specifically, what we call the clean energy paradox of this completely incredible metal. Let's just jump right in. Think about the hidden backbone of the whole clean vehicle revolution. We're seeing EVs everywhere, right? Cruising silently down the streets, promising us this amazing green future. But what's actually making this massive global transition possible behind the scenes? Well, the answer is raw lithium. It might just look like a dark, kind of unassuming sliver of metal, but make no mistake, it is effectively the magic metal powering modern EVs. It's a highly reactive, silvery white alkali metal. And get this, it's actually less dense than water. Literally, if you drop a piece into a pool, it won't just react like crazy, it actually bounces right on top of the water. Because it's so incredibly reactive with oxygen and water, it usually has to be stored in oil just to keep it stable. So, why do these quirky physical properties make it the absolute, undisputed champion of the EV battery world? Well, being the lightest metal on Earth, with an atomic number of just 3, gives its unique chemistry an incredibly high energy density. Translation? It can store a massive amount of power for long-range driving without adding a ton of heavy bulk to the car. Plus, it enables those lightning-fast charging capabilities that we all absolutely demand these days. Now, despite all this modern utility, lithium isn't some brand new invention. As you might remember from the periodic table, it's a fundamental elemental building block. It was actually first discovered way back in 1817 by Johann A. Arfvedson over in Stockholm. The name lithium even comes from the Greek word lithos, which just means stone. That's because, unlike other alkali metals back then that were found in plant materials, lithium was first discovered locked away in minerals like petalite and sputamine. It's kind of wild to think about its ancient, rocky origins compared to how we use it today. Moving on to Section 1, the EV demand shock, surging towards a clean future. Automakers are rapidly phasing out traditional internal combustion engines, with many pushing for 100% electric targets by 2030. And that brings us to a pretty wild number, 40%. That staggering statistic represents the surge in global lithium demand for EV batteries just between 2022 and 2026. Adoption is at an all-time high, and the mining supply chain is basically scrambling to expand just to keep pace with these targets. But if you think that's a big jump, brace yourself for this one, 500%. Projections show that global lithium demand is going to explode by over 500% by the end of this decade. I mean, we aren't just talking about regular market growth here. This is a massive tectonic shift in how the entire world powers transportation. So, with demand skyrocketing, where is all this essential metal actually coming from? Let's get into Section 2. Where is lithium mined? From rock to brine. We really need to talk geography for a second. First, there's hard rock mining. You start with massive spodumene crystals. This is a natural mineral state found in special igneous rock deposits called pegmatites, and then extract the isolated raw lithium from that. This method involves intensively, physically breaking up these rocks. Right now, this is the dominant method in places like Australia, which is actually the world's leading lithium producer, along with parts of Canada and Africa. But then, if you pan over to South America, you hit what's known as the Lithium Triangle. That's Chile, Argentina, and Bolivia. This region holds vast, largely untapped reserves, but they don't generally mine rock down there. They use the second major method, brine extraction. They literally pump lithium-rich, incredibly salty water from huge underground reservoirs right up to the surface and leave it to evaporate. And that brings us to the core tension of our explainer today. Section 3, the clean energy paradox and its hidden costs. We're extracting this metal specifically to fuel clean vehicles and cut down global carbon emissions, right? But the traditional process of getting it out of the ground carries from completely unexpected and frankly severe environmental tolls. On one hand, hard rock mining requires extensive land clearance. We're talking habitat loss, soil erosion, and, ironically, really high carbon emissions because the machinery is so incredibly energy intensive. On the other hand, brine extraction consumes just massive amounts of water in naturally arid environments. It diverts water from local farming, degrades the land, and seriously impacts food security for local communities. It's this profound irony of, well, dirty mining for clean cars. There's a quote directly from our source material that I think hits the nail on the head here. It says, "The lithium mining industry is challenged to balance the soaring demand driven by EV production with the urgent need for sustainable practices." There is just immense pressure on the industry right now. The economic benefits are huge: jobs, infrastructure, all of that. But they absolutely have to be balanced against the rights, health, and ecological resilience of local communities and indigenous groups. But don't worry, it's not all doom and gloom. Let's look at Section 4, Tech Solutions for Tomorrow, Solving the Paradox. The industry definitely isn't sitting still. We're seeing some incredible, cutting-edge innovations emerging specifically to clean up this supply chain. When you compare traditional methods with new tech using the 2026 projections, the data is wild. Traditional brine extraction can use up to 500 cubic meters of water per ton, but newer methods, they slash that down significantly, and battery recycling brings it down to almost zero. It's concrete proof that sustainable resource management is actually entirely possible. So, what exactly are these new methods? Well, the first real game changer is DLE, or direct lithium extraction. This is a transformative technology that rapidly extracts lithium from brine using chemical and physical processes. The reason this is such a big deal is that it completely bypasses those massive, environmentally destructive evaporation ponds that can take months or even years to process. It creates this closed-loop system that uses a fraction of the water, which directly solves those severe water scarcity issues we talked about in South America. And then, of course, we have the ultimate long-term fix, battery recycling. Instead of constantly digging new holes in the ground, we're finally moving toward a circular economy. End-of-life EV batteries now have over a 90% recyclability potential. We can recover the lithium, the cobalt, the nickel directly from old cars. I mean, this fundamentally eases resource scarcity, slashes mining waste, and drastically minimizes our need to greenlight new disruptive extraction projects. But it's not just about how we mine, it's also about how we monitor the whole shebang. Platforms like Farminaut are using a really clever three-step digital approach to bring total transparency to the industry. Step 1 is real-time satellite monitoring to keep an eye on land and vegetation health. Step 2 uses AI tracking to precisely measure the carbon footprint and water usage. And Step 3, blockchain-based traceability. This means creating a verifiable, completely tamper-proof record from extraction all the way to recycling, ensuring the lithium in your car was ethically sourced. It just brings total accountability to the global operation. Which brings us to a final thought to chew on. Can we fuel a clean energy future without compromising the planet in the process? We've seen the unbelievable surge in demand, the severe impacts of doing things the old way, and the pure brilliance of these new technologies. The transition to electric vehicles is absolutely essential, for sure. But the real takeaway here is that true sustainability means looking critically at the entire supply chain. It's a massive puzzle to solve, but by demanding transparency and embracing innovation, the solutions are literally right in front of us. Thanks for joining me for this explainer. Keep asking those hard questions, and I'll catch you next time.